Section 2.2, Quantifying the change in a variable. The word variable means changing. In mathematics, a variable is a measurable quantity whose value changes or varies. Some examples of variables are listed below. The height of a person will change over his or her lifetime. The population of a particular community will change over time. The surface temperature of the Earth will change at different altitudes. I'm going to scratch out the word average there. The concentration of contaminant in a lake changes over time. The amount of energy you consume in a year also changes from year to year. It's common to represent variables using letters. For example, we might choose the letter P to represent the population size of a community, or we might choose the letter C to represent the concentration of contaminant in a lake. Generally, we choose letters that will help us remember what they represent. Now that we know what variables are and how to represent them, we're ready to talk about changes in variables. Understanding how variables change is crucial for understanding the world around us. For example, understanding how the pollutant concentration in a lake changes over time, that helps us assess the severity of the problem. Understanding how your energy use changes over time can assist you in making choices to reduce your consumption. Understanding how the population of a city is changing can help urban planners make informed decisions about managing the city's resources. In this chapter, we discuss 3 ways that the change in a variable can be quantified. We will talk about total change, we'll talk about factors, and percents. In this screencast, we're going to focus on total change. Let's look at example 2.6. So suppose the population of a city a few years ago was 22,000 and now it's 14,500. How many fewer people are there? To answer this question, we would do a subtraction. We take our 22,000 people, we subtract off how many are still present, and the result will tell us how many people we've lost. In other words, how many fewer people there are. In this case, it's 7,500 fewer people. This answer gives the actual amount of decrease. This is referred to as the total decrease. Similarly, if a community of people would increase or grow, we could calculate the total increase. In mathematics, we have one term that encompasses both total increase and total decrease, and we call it total change. Consider a variable v whose value has changed, maybe over time, from v1 to v2. So, for example, v could represent the population of a city, as in our example above. v1 could refer to the population a few years ago, and v2 could refer to the population currently. The total change in v is the actual amount by which the value of v has increased or decreased. We write the total change in v as follows. The triangle that you're seeing here is actually the Greek letter delta. In many applications of mathematics, the Greek letter delta represents the change in some variable. When we write delta v, we're talking about the total change in a variable called v. We calculate the total change in v by taking the ending value of v and subtracting off the starting value of v. And here we've written it in words. It's always the ending value minus the starting value. Now, this definition has a really important consequence that's imperative to understand. Suppose the variable v increased over time. To think of a particular context, imagine a city and its population was growing over time. So our variable is the size of the population, and if it's growing over time, then think about what would be true about the total change in the population. The ending value of the population would be the population at a later time. The starting value of the population would be the value of the population a few years earlier. If you subtracted the starting value from the ending value, what kind of a number would you get? If the population was increasing, you'd get a positive number. So the total change would be positive. However, suppose the population of your city was decreasing. The ending population would be the population later. That would be smaller than the starting value, in other words, the earlier population. If you subtracted, what would happen? You would get a negative number because the ending value, the later population, is less than the starting value, in other words, the earlier population. So in this case, the total change would be negative. Let's recap this. The total change in a variable v will be negative whenever the value of v decreases, and the total change will be positive whenever the value of v is increasing. If we know the starting value of the variable v, namely v1, and we also know the total change in v, that's delta v, we can use these two pieces of information to determine the ending value, v2, as follows. The starting value, v1, plus the change in v should equal the ending value. This should make some sense. Think again of our variable v representing a population. If I know the population value a few years ago, that's the starting value, and I know how much the population changed by, if I add the two together, I should be able to determine the current size of the population, in other words, the later value. Let's apply these ideas to the example we saw at the top of the page. The starting value in the example above was 22,000. That was the size of the city a few years ago. The ending value was 14,500. That was the current size of the population. According to our definition of total change, the total change in the city would be found as follows. Delta V, which is the ending value minus the starting value, would be 14,500 minus 22,000, which gives us a negative 7,500. The total change is negative, which tells us that the population has decreased by, and this is a mistake, it should be 7,500 people. So this is an illustration of how the change in a variable will be negative if that variable is decreasing. Now we can also see an example of this equation. If we take the total change and we add it to the starting value, we can obtain the final value. So if I take the starting value of my population, which was the population a few years ago, and I add to it the total change, which, still a mistake here, this should be negative 7,500. If I add these two quantities together, I should arrive at the current size of the population, which I do. Let's look at examples 2.7 and 2.8. Go ahead and pause the recording now. Work the parts of both of these examples on your own, then continue playing the recording to see these examples fully worked. In this way, you can check your own understanding. Okay, let's go ahead and work example 2.7. Different starting and ending values of a variable v are given in the table below. In each case, determine the total change in the variable. In the first row, the starting value is 10 and the ending value is 14. So this is a variable whose value has increased. We calculate the total change by taking the ending value and subtracting the starting value. So the total change is 4. In the next row, the ending value is 350. The starting value is larger, 500. So this variable decreased in value. The total change is the ending value minus the starting value. It's negative in this case, reflecting the fact that the variable decreased. The total change is a negative 150. Example 2.8. Suppose the starting value of a variable x is 20. Determine the final value of the variable x if, now in parts A and B, you're told information about the total change in the variable x. Given that we know the total change, we should be able to calculate the final value. Let's look at part A. We should be able to calculate the final value, which we could call x2, by taking the starting value, x1, and adding to that the total change in x. The starting value is 20, and the variable changed by 14. It's a positive 14, which means x increased by 14 units. So the final value is 20 plus 14, namely 34. Let's look at part B. The final value of x, again, is found by taking the starting value and adding how much change occurred. The starting value is the same, 20. In this case, the total change in x is negative 3. That means the value of x decreased by 3 units. If I take my starting value and I add to that my total change, notice I really just end up subtracting 3, which reflects the decrease. The final value is therefore 17.